seems, towards more clinical research being done. This gets to a broader point. We've already alluded to the incredibly slow timeline for rapamycin's transition into humans. And the net result of that was a drug that, was not a profitable drug, presumably for Pfizer, for very long. And as a result of that, there has been a relative lack of interest in studying rapamycin, and instead an interest in looking at other drugs. Let's talk about one of them now. So Everolimus, which I believe at the time was sort of part of the Novartis portfolio. Is that correct?
I think so, yeah.
So tell us, how does Everolimus differ from rapamycin before we get into talking about one of the more important studies in humans?
I don't quite remember, but it's a small modification. I thought it was a methyl group on
Okay.
rapamycin. Ironically, the original patents on rapamycin did a very poor job of covering obvious derivatives of rapamycin. I was involved in some intellectual property cases that basically boiled down to, in the patents, they talk about rapamycins, and Wyeth, who owned those patents, Wyeth Ayers, that Pfizer eventually bought, was trying to make the argument that covered a lot of these derivatives. Eventually it was ruled that was not the case. And so therefore a lot of these so-called rapalogs, these derivatives, are actually quite simple derivatives of rapamycin that almost many chemists would come up with. And Everolimus is one of those. Since then, there's been more sophisticated variations, but Everolimus is, I think, Matt, a simple variant, right?
I think you're right. And again, maybe just for context, correct me if I'm wrong, David, but I think we can say that, there are these classes of what people call rapalogs, which are all going to be chemical derivatives of rapamycin, but biochemically, they work by a pretty similar mechanism. They all bind FKBP12, and then it's that complex that inhibits mTOR complex 1. And I think the real differences are more around bioavailability, maybe tissue distribution, and how long the drug lasts before it gets metabolized. I think all of these things are broken down by cytochrome P450 enzymes, and so you're going to get differences in peak and trough levels based on the bioavailability and clearance, and then maybe some differences in tissue distribution. But I think those are the primary things that differentiate the rapalogs. Biochemically, I think they're all pretty similar.
Yeah, no, I tend to view them, and certainly in cells and culture, they act identically. I think from a biochemical point of view, they're at least the original rapalogs were pretty much identical. And in many cases, frankly, I don't want this to sound pejorative, I think they were patent plays. I think they were ways to try to get a new chemical entity that then had a longer life than rapamycin. I think even Wyeth Ayers did that, right? They had a molecule, I think CCI779, I think was its name, which was a simple rapamycin derivative, and a lot of their cancer studies, they used that molecule instead of rapamycin because, as we spoke, rapamycin basically became off patent very early.
It's interesting, by the way, how expensive it still is, even as a generic drug. It's still a comically expensive drug, but it speaks to probably the lack of alternatives.